we're going to be covering section 2.6. Based on the other class, we won't get this finished, but I'm pretty sure we'll get this topic finished by tomorrow. If you're wondering about your tests, I am working hard at them, but they are taking a long time. My goal is sometime Wednesday evening. So be on the lookout for an email Wednesday evening, and it'll tell you everything you need to know, not just what you got in the test, but what your grade is. So we are going to be looking at limits at infinity. 5 kinds. We're doing rational fractions that involve powers. Then we're going to do ones involving square roots, and that's what we're going to get covered today. So I'm going to jump right into the first kinds of questions, and that is rational expressions that use powers, positive powers. So an example of that would be the limit as x tends to infinity of 7x cubed take 4x squared plus 1, 6x cubed minus x. There's a typical example of this situation, right? Polynomial on the top, polynomial on the bottom. Now, the way that you're going to do these questions is to follow these steps. Step 1 is find the largest power of x. Okay, would you agree that in this expression, the largest power of x is x cubed? Great. Okay, so in this case, it's x cubed. And step 1 and step 2 really get done together, but I'm separating them out. Divide the top and bottom by this power, in this case, by x cubed. Now, it's a little bit of magic, you know, why this works. But essentially, dividing the top and bottom by x cubed is really multiplying by a special version of 1. The special version of 1 is 1 over x cubed on the top over 1 over x cubed on the bottom. Do you agree 1 over x cubed over 1 over x cubed is 1? But 1 over x cubed is easier to think of it as a divide by x cubed, right? Multiplying by 1 over x cubed is ugly. Dividing by x cubed in most people's brain is easier to fathom. So that's step 2 coming up. Done. So you got a 7, 4 over x, and a 1 over x cubed, which I'm happy about. We get a 6 and a 1 over x squared, which I'm happy about. So the original has now become this ugly looking limit that's got the same value, right? Mathematically, they're equivalent. And now what I'm going to do is essentially brute force. And brute force is you replace x's with infinities. Now, I'm only going to do cubes and squares once. Typically, you just call that 1 over infinity. Would you agree infinity cubed is still infinite? And infinity squared is still infinite. So normally you just say 4 over infinity, 1 over infinity, minus 1 over infinity. Now, what does brute force tell us? It tells us that we can replace this guy by 0 and this guy by 0. Would you agree that 4 over infinity is essentially nothing, right? It's infinitely small. So what you get is 7 take away 0 plus 0, and you get 6 take away 0, and the answer is what's left. Step 3, you calculate. So it's like a 3-stage process, and there's your answer. 7, 6. Do one more of these. Let's do a negative infinity version. Okay, so let's do 4x squared plus 10x minus 1 of 2x squared minus x. Again, would you agree the highest power of x is x squared? I now have the limit as x tends to negative infinity, 4, 10 over x, 1 over x squared. Divide that by x squared. And that. Well, don't need to do that. I can now do brute force. Okay. It's not a big deal if you call these guys infinite or minus infinity. And the reason why it's not that big a deal is, would you agree that 10 over negative infinity is 0, and so is 10 over infinity 0? So it's not going to be a big deal if you misquote the positive or negativeness of the infinity in the bottom. To give you an example, see that x squared? Isn't that technically negative infinity being squared? And in that case, wouldn't that be plus infinity? Whereas this is just x, in which case that is negative infinity. Now, in general, I don't tend to make too much a deal of that, because 10 over infinity or 10 over negative infinity is still going to give me 0. If you want to be really particular about it, plus 0. But in this case here, adding 0 or taking away 0 doesn't really change anything, isn't it? Still nothing. So 4 on the top, 2 on the bottom. The answer is 2. So the limit as x tends to negative infinity and the limit as x tends to positive infinity. Would you agree in those questions the answer is pretty much the same, right? You do the same process. If you want to be lawyer-esque about it, I guess you should be a little bit careful about whether it's a plus or a minus on the bottom. But at the end of the day, aren't they all going to just turn into zeros anyway? So it won't really harm much. You know, it's good to be right, but it doesn't harm things if you don't get it quite right, because you're still going to get to. Are we comfortable with those types of questions? The limit as x tends to infinity of a polynomial, or the limit as x tends to negative infinity, right? It's the same process. I'm going to stick to plus infinities for most questions now, just to be, it's less hassle than me having to write negatives all over the place. That's the only reason. Now we're going to look at a different situation, just a little bit different. Oh, forgot my infinity. Now, just a little different. What is the highest power of x here?
X cubed.
X cubed.
X cubed. Now, the correct thing to do then is to divide top and bottom by the biggest power of x, and that's the right question, the right way to do this. Do you know what some people do and get it wrong? They divide the top by x squared and the bottom by x cubed, because they sort of think that each guy should be divided by their highest power on the top and the one in the bottom by its highest power. That's not the process. It's one single power of x to both. Now, if you do it this way, you're going to be fine, right? But if you divide the top by x squared, you get the wrong answer. You'd get the answer 7/4, which is not right. So just watch that, right? Top and bottom must be the same guy. Now let's see what that turns into. Seven over x, 4 over x squared, 2 over x cubed, 4, and 2 over x cubed. Brute force now. 7 over infinity, 4 over infinity, 2 over infinity, 4, take away 2 over infinity. 0, take away 0, add a 0. 4, take away a 0. At the end of the day, we got that. What is that equal to?
0.
And there's your answer. That the limit of this function as x tends to infinity is 0. If you put that into Desmos and sketched it, I bet you it would finish life like that. Can you imagine a horizontal asymptote tending towards 0? It would flatline. If you did this question up here, right, the one that was 2, and you did a Desmos sketch, it would probably flatline them too. It could come from the bottom, I can't guarantee it, but wouldn't it flatline it too? So you can see the difference between this one and that one, right? 0 and 1. The math is exactly the same. Would you agree the math did not change? Right? You still divided by the greater power of x, in this case x cubed. You did the brute force and you came to the same conclusion. Sometimes it's a number, sometimes it's 0. Are we good with that one? Do you want another one of them, or do you feel if that situation happens, you're good? What do you want?
Would it
I'm
be the
good.
same if the smaller power was in the denominator, so the 0 was in the denominator rather than the numerator?
Oh, you are reading my brain. That's going to be my next situation. And the
Okay.
answer is, no, it's not the same answer. It is different. Are you okay with this way round? Or can I go to that situation now then? Okay, let's do that situation. So let's do the limit as x tends to infinity. But we'll put the higher power on the top. So let's have 7x to the 5, take away an x to the 4 plus 1. And on the bottom, we'll have 3x squared plus an x plus a 7, right? Now, we're not going to change the major rule. And the major rule is divide top and bottom by the highest power, right? Now, did you see in this case, it's still x to the 5. Excuse me. So what's that going to become? Well, let's find out. Divide that, you get 7. That guy's going to get you 1 over x. That guy's going to get you 1 over x to the 5. That guy's going to get you, what, 3 over x cubed, 1 over x to the 4, and 7 over x to the 5. Are we happy about that, right? Dividing all those terms by x to the 5, that's what we get. Some pretty messy looking fractions. Brute force. 7 take away 1 over infinity plus 1 over infinity divided by 3 over infinity, 1 over infinity plus 7 over infinity. Are you all happy about infinity 5 is just infinity, right? Make everybody infinite. Right. Now, 7. That's 0. That's 0. That's 0. That's 0. And that's 0. Which means we now have that at the end of the day. That is not equal to 0. You used to call that undefined. We're not going to call it undefined. We're actually going to find out what it is. And it's only one of two things it's going to be in this particular situation. It's going to be plus infinity, although we don't normally write the plus, or it's going to be negative infinity. It has to be one or the other. It won't be both. It won't kind of zigzag up and down. Not if it's a polynomial. Other things it might, but not if it's a polynomial. So how do you think we decide between the two choices? Because we know it has to be one of them. How can we decide?
If there's a negative sign in front.
What do you mean by a negative sign in front?
Again,
How
kind
do
of
I
the
decide that 7
0.
over 0 is one of these? That's my question. Any ideas, anyone? Okay, there are three. Right, there are 3 ways to do it. Jesse said graph it. Yeah. If I put this into a calculator and it went like that, wouldn't that be plus infinity? If I put this into the graph and it went like that, wouldn't that be negative infinity? So you could graph it. Not a problem with that. That works. There are 3 ways to do it. I'm going to show you all 3 and then you pick the one you like. So maybe you like graphing, in which case you don't really want to hear the other 2, but I'm going to tell you anyway. Graphing works. Give me another way of doing it, of deciding.
Someone says infinitesimals, but they say it's loud where they are, so they didn't say it.
Yeah, infinitesimals could be done, but you'd have to know whether a 0 plus to the power of 5 was bigger than a 0 plus to the power of 3. It'd be doable, but it's not. I won't count that as one of mine, so no, I'll kick that one out. But it's a good thought process. I'd rather you came up with it rather than me tell you, because I like someone saying graphing, because that kind of makes sense. If we get another version, don't think high tech, think low tech.
Did you make a table?
Yeah, why don't you just plug in the number 1,000,000? You don't even need a table. You know, if you plug in 1,000,000 and the answer is 22 trillion, doesn't that mean plus infinity? And if the answer is negative 22 trillion, it means it's negative infinity. So just pick it, pick a big number like 1,000,000 or 1,000. Probably 1,000 will do, and you'll get the answer, right? So you could just do it graphing, right? You could do it numerical. Third possibility. Let me show you the third way of doing it. And I'm not pushing this method. I'm saying, oh, I want you to do it this way. I want you to do it whatever method you like. Plug it into Desmos. I like that method. I'm doing it. Get my calculator and plug in 1,000. I like that method. I'm going to do it that way. Or this way. Do you know the 2 little wavy signs that look like Olympic colleges waves? Do you know that means approximately the same as? That's what it means. I am going to take this guy and I am going to tell you that when X is really large, it behaves like that guy. See, if X is 1 billion, isn't 1 billion to the power of 5 1 billion times larger than X to the 4 is? So numerically, won't the only one that really matters in the long term is the first big power. Now that guy can be simplified down to that guy. And that guy is 7/3 times infinity squared, which is what? Positive infinity. Now, suppose this question had a negative infinity here, right? So it's the limit as X tends to negative infinity. Do you know all this working would be exactly the same? Right? Minor differences, maybe that's going to say minus infinity, but isn't 1 over minus infinity still 0, so it won't make any difference. Now, it's still a decision. Is it plus infinity or is it minus infinity now? Well, if you plug it into the graph, you'd see that picture. So it's negative infinity. If you plugged 1,000 in, you get 1,000 minus 1,000 billion or something like that. That would prove it was minus infinity. If you do this method, you get, oh, I'm just saying negative. I just realized the answers are positive. Check that one out. Right. Is it negative? Yes, it is. We get that. It's negative infinity. So you can use the methods. I'm not going into this one anymore. I don't like it. But graphing and numerical will do it. And the other one is a shortcut. Well, I'm not sure it's such a shortcut, but it is algebraic. You want to see another one where it's plus or minus infinity? Are we good? Another plus one, just like the one we did?
Why not?
Yeah, okay, I'm doing it. There's not enough commitment for no. Well, let's do a negative infinity. There's a guy. Going to divide top and bottom by x squared. It's now going to be the limit as x tends to negative infinity of 1, take away 4 over x plus 1 over x squared, 2 over x plus 7 over x squared. Now, when you do the brute force, technically speaking, if this is negative infinity, if I wanted to be really lawyer-esque about it, shouldn't that be 4 over minus infinity? But shouldn't that be 1 over plus infinity? Because negative infinity squared is positive infinity. This fella here should be that guy, and this fella there should be that guy. So if I'm being really pernickety about the infinities, some of these are plus and some are negative. Because infinity squared will get you infinity, whether it's plus or minus, whereas negative infinity. Why I'm not too, going to get caught up on that. Doesn't the answer still end up 1 over 0, whether you call it 5 over infinity or 5 over negative infinity, right? You end up with the same destination. Now, we know that that is a plus or a minus infinity. Okay. Do it in Desmos and you will get negative infinity. Plug in a number like minus 100. Yeah, I'm trying to think of one like minus 100, minus 1,000, right? Negative, big negative number like that. It will give you negative infinity. If you do the simplification method, doesn't that behave like a half x? A half x. If you plug in x in there, isn't half of negative infinity, and so that agrees with negative infinity. So whatever one of the three methods, negative infinity is the answer, right? You plug it into the graph and you look at it, you plug in negative 1,000 and you see if the answer is big and positive or negative, or you do my little surgery thing and see what it looks like. All three techniques have their pluses and minuses. Whatever one you like, I'm cool with it. Yeah, I feel a little bit better to do another one because I kind of ranted on a little bit in the last one and we might have lost the direction of the question.
I have a question. Could you go back to the previous page for a second? So at the end of the last question, you had 7x to the 5th over 3x squared, and then you took out the squared.
Yeah.
So if you were to just evaluate right there instead of taking out the infinity first, you'd have 7 times infinity to the 5th, which is just infinity, over 3 times infinity squared, which is just infinity. So you'd have infinity over infinity, and wouldn't that be 1 instead of infinity?
No. You're treating infinity like it was a number like 10. Infinity over infinity is not 1. And that it might seem strange to you because you're used to if you write the same symbol, it means the same thing. Infinity is much more like a placeholder for a very big number. So side issue, but I don't know if this will help, but here's an analogy for you. Suppose I made a fraction where the top was the number of whole numbers that there are, and the bottom was the number of fractions that there are. Right? Now, would you agree that there's an infinite number of whole numbers, right? 1, 2, 3, 4, forever. And would you agree that there's an infinite number of fractions? Now, if you said infinity over infinity was 1, then aren't you saying that there's the same number of both, right? Essentially. Let me try and argue why that's not the case. There are many, many, many more fractions in the universe than there are whole numbers. For instance, between 1 and 2, isn't there 2 whole numbers, 1 and 2? Between 1 and 2, isn't there an infinite number of fractions? 1 1/2, 1 1/3, 1 1/4, 1 1/5, 1 1/6. I can do that, right? Isn't there infinitely more fractions in the world than there are whole numbers? Even although both of them are called infinity, isn't there degrees of infinity? In other words, some infinities can be bigger than other infinities. And because of that, infinity over infinity is danger zone. You cannot assume it's 1. In fact, you'll find out in future that you may get a calculation that looks like that. By the way, it's called indeterminate form, just like 0 over 0 is called indeterminate form. So is infinity over infinity, called the same thing. The infinity over infinity can be 1, it can be 0, it can be 42, it could be infinity, and it could also be negative infinity. In other words, it could be anything. And you get that by having different versions of infinity on the top than you have on the bottom. And so the concept of infinity is different from numbers. So you can't do what you wanted. It's trickier than that. That was a good question. I like the question. Okay, let's do square roots now. So let's do the limit as x tends to infinity of the square root of x to the 4 plus 2x plus 1 all over 4x squared. So that's an example of a fraction, right? A rational with a big square root in it. Big ugly square root. Now we are going to do the same technique, so that's good. But we're going to have to adapt it. So first things first, we need to find the biggest power of x that's in this expression. Well, on the bottom it's easy, it's x squared. In fact, let me put something else there just so it's not just x there. How about that? Right. So we know it's x squared. The top power of x is not x to the 4. Superficially, that looks like it is. But isn't that x to the 4 inside the square root? So what is the true value or worth of x to the 4?
X to the 2.
Yeah, it's x squared. So top's worth an x squared, bottom's worth an x squared. Great. Biggest power of x is an x squared. Let's kick in to phase 2. That guy is 4, and that guy is 4 over x squared. Oh, darn it, that isn't going to be easy. You should be saying to yourself, because you can't really divide x squared with a thing that's in the square root. They're not allowed. I'm not allowed to call that x squared plus 2 over x, plus 1 over x squared, because that's not what's going on there. This guy has to be converted into x squared, but using a square root. Would you agree that the square root of x to the 4 is the same thing as x squared? So I'm actually going to divide the top right? Everything on the top by the square root of x to the 4. And that makes it algebraically correct. Does it make sense that you can't divide things inside square roots unless the thing you're dividing has a square root, right? You know, me and you have to be the same guy. Now, when you do it in that way, you then get the correct terms that are going to go inside. So that's the bit that makes it a little bit different from what we've done. But that's about the only bit that makes it different, right? That you have to kind of adjust how you divide because of the square root thing. Well, let's see what that looks like with brute force. 1 plus 2 over infinity plus 4 over infinity over 4 plus 4 over infinity. And that gets me 1 plus nothing over 4 plus nothing. And that gets me 1, right? Square root of 1 is 1 fourth. So this ugly rational function with a square root, as x tends to infinity, the answer is a quarter. Are you okay with the adaptation to accommodate the square root? Right. Do another one. I'm going to do another one with a number. Then I'm going to show you a square root where the answer is 0. And then I'm going to show you a square root where the answer is plus or minus infinity. That way we've kind of covered the same situations. So another one where the answer is going to be a number. There we go. Okay, what's the biggest power of x in that expression?
Is it the fourth power?
That's
I can't
it's
see a
X
fourth power.
cubed.
Yeah, I'm not sure where the fourth power is. That's a 6. It's not that. It's cubed, right? X cubed and the square root of x cubed. So x cubed it is. Agreed? Right, let's move to the next fella. Got a 2, a 4 over x squared, a 7 over x cubed. That's good. Oh, won't we have to call this guy the square root of x to the 6? In fact, after you've done a couple of these, you'll probably never write that. Won't you write divided by the square root of x to the 6 on the bottom? Just don't bother writing that after a while. So back to our question. That fella divide, you get 4. When you divide this fella, you get 1 over x to the 5. And this fella, you get 1 over x to the 6. So we now do the brute force. 4 over infinity, 7 over infinity, square root 4, 1 over infinity minus 1 over infinity. What's that? 2 plus 0, take away 0. 4 plus 0, take away 0. 2 on the top, square root of 1. There we go. 1 is the final answer. We feel comfortable about the square root, guys, at least the ones that are numbers, which are these two, this one and the previous. Right? It's nice when the technique's pretty much the same in two different situations, right? When it's just polynomials, you did divide by x cubed. When it's square roots, you still divide by x cubed, right? So square roots, but when the answer is 0. Okay, the biggest power of x on the top is x cubed, but what's the biggest power on the bottom?
X to the 4th.
Square root of x to the 8, which is exactly x to the 4. Let's see what happens when we do this. We get 5 over x, 1 over x cubed, and that guy. And then the square root fellas, you get a 1 over x to the 4, and a 1 over x to the 8. So brute force now. 5 over infinity, 1 over infinity, 7 over infinity, square root of 1 plus 1 over infinity plus 1 over infinity. All happy about the brute force, right? All the x's and powers of x are now infinites. Right, 5 over infinity and all the other guys on the top are going to get me zeros. On the bottom, 1 plus a 0 plus another 0, 0 over the square root of 1, hey, 0.
What would happen if you had x squared over, say, the root of x to the 5th power?
Very good question. Do you want to see that right now? Okay. So the question was, and I'll put some other terms, right? Suppose you had this guy over, say, an x to the 5. Yeah, something like that, say, right? That guy is x squared. That guy there is a very ugly power. He's actually a fractional power. And that fractional power is 5 halves, isn't it? Square root of x to the 5, 5 halves. So the top guy is going to be 5 halves. And the bottom guy, thank goodness, at least I can make him look nice. Now, if I did this fella, what you would get, bear with me, is the limit as x tends to infinity. Well, let's do the bottom guy first because he's easier. 1 over x cubed minus 1 over x to the 5. Now, you won't like this, but this is what you're going to get. X squared divided by that guy gets you 1 over x to the half. Yeah. This guy divided by that guy gets you 1 over 3 halves. And this guy divided by them gets you 1 over 5 halves. Are you happy about the really ugly fractional 1 over xy things that you get? The good news is that it doesn't actually cause too much trouble after that. Would you agree that 1 over x is 1 over infinity? Well, isn't 1 over x to the half just 1 over the square root of infinity? And isn't 1 over the square root of infinity still infinite? So what you end up with is 1 over infinity, 1 over infinity, 1 over infinity. You see, it's not that bad. It just turns into infinities anyway. And this fella is a 1 plus a 1 over infinity, technically. Take away 1 over infinity. So I have 0 plus 0 plus 0 on the top, and the square root of 1 plus 0 zeros, 0 over 1, I get 0. Intuitively, does that seem reasonable, what you have to do, right? So you could do it with fractional. Well, we won't see too many of them because they're kind of clunky, but you could, right? So that's what happens with a square root where the answer ends up being 0, right? So there's just time to show you the last situation. So here goes. It doesn't matter where the square root is. Do you want it in the top or the bottom this time for the last question?
Top.
Top gets the job, okay. So I'm going to make this answer infinite. So I'm going to have an x to the 6 plus 2x cubed on the top. 3x squared minus 2x plus 1 on the bottom, right? Okay, what's the highest power of x?
X to the third.
Agreed. And I'm going to use the square of x to the 6 on the top one, like we did in all the other situations like that. So it's now going to be the limit as x tends to infinity. Oh, that into there gets you 1. That into this guy gets you 2 over x cubed. This guy into him, 3 over x, 2 over x squared, and 1 over x cubed. Are we happy with where these pieces came from? Right. Time for brute force. On the top, I get square root of 1 plus 0. On the bottom, I get that, which ends up being 1 over 0. And we've seen 1 over 0 before. Don't we know the answer when that happens, in these questions at least, is plus or minus infinity? So can't you plug in a Desmos and see what happens? Can't you plug in 1,000,000 and see what happens? Does anybody know, just, I guess, gut feeling, for want of a better word, what you think the answer is? Plus or minus infinity?
Gut
Plus
feeling
infinity?
negative?
Yeah, what's your gut feeling, Sabrina?
Gut feeling negative?
Oh, your gut's telling you the lie. Give it into a row. Well, I'm not asking you what the answer is. Based on what I just said to poor Sabrina, it's plus infinity. But, you know, plug it into Desmos and do it that way, or plug it into, or plug 1,000 in. Do you know that little shortcut technique that I showed you for the other situations? It's probably not worth it in this one because it's so messy, you'll probably screw up the answer. So stick to Desmos graphing or numerical for these kinds of questions. I could argue, and this is just totally off the top of my head, isn't that a guaranteed positive answer because it's a positive square root? And would you agree that 3x squared is going to win? So would that be a positive number as well? And a positive thing with a positive thing gives me a positive answer. That might have been my logic through it. Were you thinking the same thing, but introduced the negative somewhere?
Yep.
Yeah. So your thought process was right. Just the application of it was a little bit. But that's a good thought process, right? Isn't it? Just say, yeah, the top guy is going to be a really big positive answer, and the bottom guy is also going to be a positive answer. So that means it's plus infinity. If the top's going to be a positive answer, but the bottom's going to be a negative answer, can you imagine that would generate negative infinity then? I'm making this up, but I know what the answer would be. Can you pretend that it was negative 3x squared? I mean, that's the only difference. Can you trust me that that would have a limit of negative infinity? Top answer's positive, right? Would you agree that that's negative because x squared is going to win, so negative 3 infinities is going to make the bottom a negative number? Positive thing, negative answer. And you know the answer is infinity, so negative infinity. Okay, say hi everybody and bye-bye.